Good afternoon, everybody, and welcome to the Hydrogen and Fuel Cells Europe here at the Hannover Messe 2023. You're here at the technical forum where we dive into all of the nitty-gritty details of the hydrogen sector. Please have a seat, have a drink. The hostesses are here to serve you with everything from soda to coffee. And we have some very interesting topics to talk about. Up next, we'll be talking about fuel cells in the stationary sector. I'm here with Proton Motors, Head of Sales and Marketing. Please welcome to the stage, Mr. Jean-Pierre Sevrain.
Hello, Joris.
Welcome.
Thanks for having me. Hello, everyone. I'm here to talk about fuel cells in stationary application. Hydrogen is in many discussions and is always more playing a role in many applications. We're talking about industry, automotive, we're talking about agriculture, maritime applications. And my name is Jean-Pierre Sevrain, and I'm working with Proton Motor. And today I will talk about stationary applications. Next. But maybe shortly, who is Proton Motor? We are a pioneer in the area of fuel cells. We exist since 25 years. This year is the 25th anniversary of Proton Motor. And we have always believed in fuel cells solutions. We are in Bavaria, near to Munich. And we engineer fuel cells. We assemble them. We integrate them. So in what we call turnkey solutions. Also for maritime and mobile users. This year, we are moving into a much larger facility, which is about 3 times the size of where we are at the moment. So we will be able to produce more product to save the world from the climate. Why do we address stationary systems applications? This is about the carbon footprint in using hydrogen as a fuel of the future. We are talking about solutions keeping our capability of sustaining our way of life. What type of application are we looking at? Seasonal energy storage, charging stations for EV cars, and so on. Off-grid power supply, emergency power supply, and grid stabilization. The off-grid power supply allows to produce electricity on remote location for electrical vehicles, short events, temporary applications. Emergency power supply, this is something which many people talk about, like basically data centers and stuff like this, where we replace fossil-based electricity generators. Grid stabilization, peak shaving, that's my favorite. We have been disconnecting the plants using turbine propelled with steams, basically gas, coal, nuclear plants in Germany, and we replace them with wind energies and solar sources. So we do not have anymore this 50 hertz turning turbines, stabilizing the 50 hertz power supply we have. And what the fuel cells can do there is just replace this 50 hertz issue. Of course, with the help of batteries, but batteries do not have this capability of long storage as the hydrogen does. And the last one listed here is the electricity and heated production. Of course, the heat can be used. If the heat can be used when you produce electricity with the fuel cells, then you have a tremendously better efficiency in terms of energy. So, how does that work? That's very simple. At the beginning, we have a stack with the 200 square centimeters, or in that case, the 400, and this provides electricity and current. This is basically the heart or the base of what Proton Motor is doing. When you have a stack, you do not have a solution. You cannot produce electricity. So that's the reason why you need a little more of components. Building a fuel cells means to develop a system that can transform the chemical process into a usable energy, which is electricity. These both outputs, current and voltage, needs to fulfill the application requirements. To do so, we have commonly what we call the balance of plant, which is made out of monitoring controls, hydrogen supply and air supply, so you have a good or a perfect chemical reaction, which is exothermic, so you need a cooling unit. And the power electronics is, of course, to adapt to the application of the customers, depending on what the customer does with it. We have 3 fuel cell systems, or product group, I would say, with the 8 kilowatt, which is all of them liquid cooled. The frames, which is a modular system, we can stack up and put parallel, and that leads to this final image where we are going into, because many customers want to have a solution, want to produce electricity, but they do not have the know-how how to work with the hydrogen, basically, to produce energy. And that's where we come in play and use our base system to integrate full solutions, which are what customers need is a support of in integration, in engineering, in fluid management, electrical planning, in also when you buy a fuel cells, then you need to connect it and to get up and running. And that's where we come also with our service, supporting our customers to implement and make a system that works at the end. So there is a long list of things which is needed out of a fuel cell system to make turnkey solutions. I don't think I need to go into the details. Basically, we respond to a need of our customer. When they want to have an off-grid system, then we supply an off-grid systems, which is something very interesting also with the stackables, is you can replace one of the stacks and let the system up and running, maybe with a lower capability, or you can bring up and running 1 or 2 of the stacks. So you start with a 20 kilowatt supply. Now I will go into a few examples of applications. Now you know how we build our systems, you know who we are. Now I show you what's the result of it. The result of it is, for example, here in Switzerland, where a customer built up a full self-sufficient house with 8 flats. The local power, which is supplied by regenerating locally produced stored hydrogen, that house has a tank inside, but I'll go later into it. And there is only an 8 kilowatt fuel cell system to provide the electricity. How? It's very simple. You need a lot of energy that you can store in the 290 kilogram, or well, the size of the tank can compose 290 kilogram of hydrogen. The power is produced by the solar panel, which is all over the roof of the house. The electrolyzer produce the hydrogen with a 14.5 kilowatt, and to take over the peaks, the requested energy, what the people living in this house, we use the batteries and drive up the fuel cells when needed. When you have a long cold night, or maybe when everybody is starting the washing machine, then you will have to use the reserve. So this project is already 7 years old and still up and running. Nobody wants to have a cold flat in winter. This is also a project which is for a much larger building complex with a 36 kilowatt base stack. Basically the same thing as what I just showed you. Here in that case we use also the waste heat of the of the thermal reactions. Now we come to the energy storage and grid stabilization. This is a wind park, industrial scaled, where the power is then electrolyzed and we can use it to feed back electricity into the grid. And this is an example how to scale up power output currently. We are working on we are working now on one new, which will be delivered next year with 6 trains and a power output of 240 kilowatt. Those are power to the grid and enormous advantage for the regulation of the load. So we can adapt our power output to the needed load. And in all the applications, this is my favorite one, which is basically off-grid power supply. That means you can take this container anywhere and put a trailer with hydrogen next to it, and then just produce 400 kilovolt with a peak power of 400 volt ampere with a 240 kilowatt peak. This will solve maybe issues where you need for a certain duration a power output. We can scale those up to, or we plan to scale up to 1 megawatt. We haven't done that yet, but we are planning on. So yes, the world will be soon different because we have to. And when most of the people will realize how easy and meaningful hydrogen is, the fuel cell is an indispensable part of the whole solution. So, if you want to know more, please visit us at the booth. Thank you for your attention.
Thank you very much, Jean-Pierre, for your interesting presentation. You showed us your favorite application, the off-grid power supply. Do you think we could use this to have like a zero emissions music festival powered by hydrogen?
Definitely.
Sounds like fun. All right, let's continue the chat with Mr. Jean-Pierre at booth B32. So if you have any questions, please go there. Thank you very much.
Thank you, Joris. Have a good one.